Okay, so in this video, we're going to talk about the inverse of a quadratic function. So when we study the inverse of a function, first we make a table and we look at the inputs and the outputs of the original function. So for this scenario here, we just did the function g of x equals x squared. So we plugged everything in and we made a table. To find the inverse of that function, we are going to switch all the inputs to become outputs and the outputs to become inputs. The first two entries in the table are kind of trivial, but if we continue moving down, we can see that if we plug in 2, we get out 4. And in the inverse function, we'll plug in 4 to get out 2. So we've reversed the inputs and the outputs. The graph of a quadratic function, the simplest one, y equals x squared, you can see here, you plug in 0 to get out 0, 1 to get out 1, 2 to get out 4. The problem here is the inverse. So when we do the inverse, we know even though they're not labeled, there is another coordinate here, -1, 1. Since these outputs repeat, when we do the inverse here, the inverse of a quadratic is not a function. And the reason that's not a function is because if you plug in 1, you would get out both +1 and -1. If you plug in 4, you would get out both +2 and -2. So if you tried to write an equation here in function notation, it wouldn't be possible because there's no function where you can plug in 1 and get out both +1 and -1. So it turns out the inverse of a quadratic is not a function. However, that doesn't mean that we're done. Just because it's not a function doesn't mean that there isn't anything interesting to study. So if we move on to our next slide here, we can see that if we just restrict it so that we only talk about the positive values, then we can discover a new function. So what I've done is said, what if I just take half the parabola so that all of those repeated y values are gone? So that's called the domain. X is greater than or equal to 0, since I'm making sure that all of my x values are only greater than or equal to 0. I've gotten rid of all the ones that are negative. In that case, I have half of a parabola, and it is the equation g of x equals x squared. When I do the inverse, when I switch 0, 0, 1, and 1, and then 2 and 4 to 4 to 2, because I got rid of this left side of my parabola, I also got rid of this bottom side of the inverse. And in that case, now this green graph right here is a function. Each input has only one output. And this is the function, the square root of x. So if I were to plug in the inverse here of 4, then I would take the square root of 4, which we know is just 2. So the square root of 4 is just 2. Each input has exactly one output. So we have this new function that we can call the square root function. It's not exactly the inverse of the quadratic, but it is interesting. There's some properties that they share, and it helps us to learn new functions and study them.